Hello and welcome to the stream today. I have Johan with me again. And as if you remember last time we spoke, we were looking at Inlets, the network tunnel tool, and all the kind of use cases there were just for basic networking. And today we're looking at how we can cross boundaries with Kubernetes networking. And Johan has some specific and interesting demos for you. And I guess we'll start at the beginning. Johan, what's kind of changed with Inlets since we spoke last, or what do people need to know about using Inlets with Kubernetes?
I guess the most important thing is that we have a lot of automation available when we are going to deploy Inlets in a cluster, either as a service, as a server, the exit nodes, but also the client part of the tunnel. And especially we have some Helm charts available there. And maybe the most important thing, if you have a cluster on-prem or in your home lab, we do have an Inlets operator available to expose or to create a load balancer with the public IP without any hassle.
That sounds like the kind of thing you would need if you're potentially managing a lot of tunnels, or maybe you're just using Kubernetes already.
Myself, yes, I'm using most of the time Kubernetes, but the Helm charts we do have, you can use them to create tunnels very easily and to manage a lot of them. That was one of the latest blog posts we wrote, and that's published, I guess, last week, where we try to scale the number of inlets to hundreds or maybe thousands.
Perhaps I can show that so that in case anybody's wondering. This was another blog post that you put together, and one of the use cases was, how can we go big, right, with tunnels, and there's a couple of things here, right? One is how can you just deploy tunnels to Kubernetes, and what options are there? So there's the client. You could run the Inlets client in a Kubernetes cluster so that you can expose something internal and private to the cluster somewhere else on the internet or in another cluster. And the other one is running the server as a pod as well, and then making that easy to manage so that if you went from needing 5 to 500 tunnels, it would really be simple and easy to manage in comparison to creating, 500 VMs, keeping track of the IP addresses, making sure they all had their networking. But why would you want that many tunnels, for instance? What kind of use cases are there for it?
Perhaps you're running some kind of software as a service product where you want to bring a lot of IoT devices. You want to monitor and scrape metrics from your IoT devices, for example, or you're running a managed service when you want to bring services from your clients on-prem. You want to make it available in your platform. So those are the typical use cases when you want to bring external services within your cluster using the Inlets tunnels.
Yeah. Amit here saying, like IoT service providers. In fact, this reminds me of a service provider that we've talked about in the past. That's actually on the main website. We scroll down a little bit, is over at Vision, where Tobias Brunner, that's now heading up the technical side of the company. They're using it to connect OpenShift instances in private VPCs and regulated institutions back to a central control plane. So that would potentially be an example, and it might be that maybe a company like Vision might have 5 of them. They could probably just run 5 VMs, or they could run 5 Helm chart install commands, or develop 5 Kubernetes YAML files to host the servers. And then the key thing is deciding whether you want that service to be available to other people on the internet, or private. Right.
Yeah.
So yeah, this was the recap that you put together for how we might monitor multiple clusters if they were each running their own Prometheus. Now, this was multi-cloud, wasn't it? But I could imagine a use case where it's all in the same AWS account at the same company, but we've got multiple teams that have their own clusters and want some overview of how much they're being utilized. You could do similar there.
Yeah, definitely. Yeah.
Okay.
And the first thing I did with Inlets already a long time ago with Argo CD. So this post is about bringing multiple services into a central Kubernetes cluster. But when I started using Inlets, that was one of my use cases. I had multiple clusters on-prem. Most of them are Raspberry Pis, but I want to control them from a single pane of glass. And I brought the API service of the private Kubernetes clusters available in the central cluster, and I could use Argo CD to deploy the applications across all my available clusters.
Yeah, that makes a lot of sense as well. Like that's almost like you're having central governance and control in place. Yeah. Now, I was actually speaking to a client earlier today, and they wondered why would you need Ingress, Nginx, and Cert Manager? What kind of role would they play if you were having one of these big hosted environments?
At the moment, we do need a certificate in place to make it more secure, and the Inlets server is capable of generating or creating its own certificates. But if you want to create multiple tunnels and you want to expose them all separately, then it can become very costly because it will create a load balancer for each one of them.
Right, yeah, because we need some way of getting that control port that's available to the outside world so the client can connect to it. That's the URL parameter you see in the Inlets client.
Indeed.
Okay.
Yeah.
So the Ingress, the way I kind of explained it was it's like with the LAMP stack, if you remember the virtual hosts, where you can have multiple domains all on one server. And that's really what we're looking at here. And then Cert Manager is most similar to something like Certbot. It goes off to Let's Encrypt, ask for a certificate, and then puts it into the cluster for you. So once you have that, and this example showing a wildcard TLS certificate again, because there is a limit on how many you can get, you would then go and create your first exit server, and this is going to be a pod, isn't it?
Yeah, indeed, it's a pod. It's a single pod running the exit server of the Inlets tunnel.
Right, and in this example, you were just doing a one-off tunnel for Keycloak, getting a secret so that you then share that with the client and go ahead and then do chart installation. Okay. Now, the thing that I found interesting here is you were overriding this so that it uses the secret we already got for the wildcard domain.
Yeah.
And then however many of these you install, as long as they all have this extension, they can all use the same certificate. So that makes it more efficient. You then went on to look at, what if you created a bash script to automate some of that, and then you could just simply declare what service you needed and what port it was going to be. And so I think this blog post definitely would be of use to me if I was running Inlets and I was thinking, okay, I roughly know how Kubernetes works, and I want to go to 10, 20, 100. And then we'd sort of show how that all works and get down to the bottom, and there's a reference back to this Inlets cloud concept here. And the real idea is that we can tap into Kubernetes a little deeper and use a custom resource. So we can actually have a tunnel resource. We can automate some of the operations, like how you can then access a service that's been tunneled securely, create, update, and delete tunnels very quickly, and get connection tokens. So I think if I was going to be running one tunnel, I would I'd create the VM myself, perhaps. If I was doing 10, I might want a small Kubernetes cluster, so each of the pods could be there. Maybe even going up to sort of 20 odd. But then if I want to get even bigger than that, having a Kubernetes operator that you make yourself, or perhaps using this Inlets cloud product would actually just make that a lot easier.
Yes.
At some point, if you think, right, we have 200 tunnels, well, where are they coming from? There's probably a pipeline or a third-party system that needs to request new ones. And so just like you have the bash script, which is great when we create them manually, we can then integrate a bit deeper. And so this is kind of one of the more advanced use cases probably for...
Yeah, absolutely.
So today we had, if I can grab this slide and bring it over here, a quick agenda, right? Just a quick recap on how Inlets works. Get Johan to show us his cluster at his house, getting ingress from the internet. If we've got time, look at this hybrid cloud use case. We just talked about the multi-cluster at the end, so we'll see if we get time for that. With the hybrid cloud, can you just tell us quickly how, let me see which diagram, how that would work?
That was indeed another blog post we put together, and the idea was that you have some kind of, like, for example, a database, or maybe another system available on your own data center on-prem, and you're migrating towards a cloud environment, and perhaps you just want to keep your data available on-prem, but you want to make it available for the applications running in the cloud. So on the left side, we have MySQL running on-prem. On the right side, we have, in this case, a Kubernetes cluster running on Google Cloud Platform. And the WordPress instance wants to use the MySQL database. And by creating a Inlets tunnel between the two, the WordPress instance is able to write the data in your own data center and still running on the cloud. So it can be useful for example, transitions towards a cloud environment, or maybe you still want to keep your data on-prem for legal reasons, or like what do you have?
Yeah, I think that makes a lot of sense. In fact, I've heard of people that have perhaps they have an on-premise application that is not fully migrated to the cloud, and what they might want to do is access a SQL database. Could be a Windows MS SQL server, could be
Absolutely.
MySQL on Linux, like you said, and then you can tunnel it to a Kubernetes cluster. You could also just tunnel it to a VM, or an EC2 instance. It doesn't really matter. But what I like about the Kubernetes approach is that it's quite easy to configure, and then once you have it working for one, like you showed us in the blog post, you can go to sort of 10 apps or 10 different clients coming back, and it's very easy to take it to the next step. Now, what other kind of use cases do we have here? Well, that was a private database. It might be that there's some legacy API service available in the company on the intranet or on the VPN. We could make that available within the Kubernetes cluster without compromising it or without exposing it, even if it didn't have authentication or TLS enabled. And that's potentially, something that you might find. Some of the medical protocols that use TCP, they aren't always encrypted, and the clients can't necessarily read that. So whether you have a service, a database, or maybe a web portal or an API, they're the kind of things we probably have on the private side. And then on the public, we would then bring it back either to control it or to monitor it, or maybe even, like you said, just to access it as part of a distributed application. Now, you're going to show us the use case for Inlets when you're running at home. That's when it's been quite popular with the community. So just to recap, there's a client side and there's an exit node or an exit server That's just the Inlets server. Both parts of these are in the same binary, whether that's Inlets open source or pro. We run the client within our network, and that's a bit like a router. So that connects to the server and says what it can expose or what can be accessed. Sometimes like the upstream, call it. When traffic hits the exit server, which may or may not have a public IP, that then goes to the client through a WebSocket. The client can then decide whether that's something that it's allowed to talk to, and then make the connection back. So in the example here, with a simple Node.js Express website, and that's being accessed through this public IP. This is more versatile than using IPsec. It's a lot easier to set up and automate. It will run in a container without additional system privileges. And you're also not forming a VPN between hosts. It's literally between the services that you've asked for. Now, perhaps we could just look at this diagram quickly then. This is one from Ivan. Really like the level of detail. Do you want to talk us through it? If we wait for the animation to restart, if I click off. So we're going to wait for this to get to the end. And then we'll just talk through this very quickly. So when you're ready, we'll finish playing. I mean, it's great what he's done here. I think it took him quite a long time to draw all of it and animate it. Okay, so he's now showing a deletion and how that cleans up all the resources. And then we should be back at the beginning of the animation. Go. Okay, tell us.
Yeah. So the idea is to create, the Inlets operator will start a tunnel as soon as you create a service of type load balancer. And that's what he's displaying here. So he created an Nginx service. The Inlets operator detects this type of type load balancer. It will create a tunnel resource in the Kubernetes cluster. It's a custom resource. And based on that definition, it will start creating an exit node on your preferred cloud provider, in this case, DigitalOcean. And as soon as the exit node is available, it creates a pod running the client of the tunnel, making the connection between the two of them. And then, in that case, your Nginx is exposed to the outside world, to the public. And then if you remove the load balancer service, of course, then the tunnel will be destroyed and the exit nodes on DigitalOcean will be destroyed as well.
Yep. That's how I would want it to work. And I remember the time when I first actually created an early version of this. I'm guessing 2019, because it was when we could still travel. I think it was late 2019, around October, and it was just like magic. I exposed the service, it created the VM, it ran the client on my side and the server on the other side, and it just worked. Like in the animation now, welcome to Nginx. It was just, so useful to be able to get that. And then that means that whether I've got Minikube or Kind or a Raspberry Pi cluster, I can get traffic in. Okay, so I think you were going to show us this one. You've got a demo ready for us, haven't you?
Yes, this one I can show you.
So hello to Amit and hi to everybody else that's tuning in. Thanks for being here. And if you're watching this later on, because we'll make this available and you guys can tune in later, watch along, think about trying it yourself. So there we are. The screen is up. Are you ready for me to add that on?
Yep.
Okay. All right. So
it's big enough?
Probably go one more closer. Maybe, yeah.
So I have a couple of Kubernetes clusters ready, and one of them is running at my home on a Raspberry Pi. That's when it's selected now. I can show with the nodes. So it's running K3s with containerd. It's a Raspberry Pi running on Ubuntu, just to show you that's running at my home. And what I'm going to do is maybe install OpenFAS on it and expose it to the outside world using the Inlets operator. So first, I'm going to install the operator itself. I'm using Arcade, of course, because that's the most easiest way to install things on a Kubernetes cluster.
It was this morning I was speaking to somebody who needed to have all of these tools, kubectl, kind, and Inlets itself. And so just being able to get them all from one command, like with Arcade install and Arcade get, could save you a lot of time. In fact, last week I did everything that's listed there on a Windows computer that I've not booted into for 6 months. So it was just really easy to get everything I needed. I used git bash, and then Arcade was able to download what I needed.
Yeah, so if I hit enter now, then the Inlets operator will be installed. Maybe a small explanation about the flags I'm using here. So I do have a license for the Inlets Pro, so I'm going to use that. So the clients will use the license, and it will use the Inlets Pro version of our tunnels. And then the token file, because I want to create exit nodes on DigitalOcean, I need an API token, so the Inlets operator can indeed create some VMs on DigitalOcean.
There's the URL if anyone wants to grab that. And you'll see Ivan's great animation there as well. Okay.
Now the Inlets operator is up and running. As soon as we create a service of type load balancer, then the Inlets operator will start creating an exit node with a public IP address, tunneling to the service, and it will be available for every one of us. Like we said earlier, maybe we can deploy OpenFAS on it, install Open.
So we've got the operator, and that's now looking for services of type load balancer. Yeah. Okay.
So I'm going to install OpenFAS with the flag load balancer so that the gateway external service is of type load balancer.
Okay, yep. And there's an example, isn't there, in the GitHub repo just for plain Nginx as well?
Yeah, I can do the same.
Okay.
If you want to. Arcade install ingress Nginx.
Okay, yeah, that's another way of doing it. We could just have an ingress controller, as long as this isn't K3s, so it might have traffic already.
I installed K3s without traffic and without internal service load balancer.
No hard feelings if there's anyone from the traffic community. That's one of the things that's kind of surprising with K3s. Sometimes you can't get something to work, and you realize you've got traffic in there, and you weren't expecting it. Okay. So interesting. Need to change your context. So we're just using the kubectx command here, which is great for just switching between any clusters you might have. Probably go a bit bigger on the text as well.
So as you can see, there are a couple of services when you install OpenFAS, and one of them is the gateway external. It's of type load balancer, and we do have a public IP address. Although I'm running on my home lab on a Raspberry Pi in a private network.
Okay.
So normally, if you hit that endpoint.
Do you want to increase the font size a little bit?
80, then normally you should be able to access it as well.
That's great. I'm going to get a screenshot of that.
Yeah. And the same for services.
Yeah, and so you have your ingress controller installed now, and that will create a separate
different
IP.
one.
Yeah. Now, if you wanted to save money on exit servers, you could just have OpenFAS go through that ingress definition, couldn't you?
Yeah, of course. Yeah, absolutely. Yeah. And now we are running just the Nginx and OpenFAS without any type of certificate. So if you make a combination with Cert Manager, Nginx, expose Nginx with a public endpoint, let Cert Manager obtain a certificate based on your host name and on your domain, and then you're good to go.
So last time we did an SSH tunnel, and I tried to connect that. So can you run the command, the post install command from OpenFAS, and just deploy node info or something, and I'll see if I can access it.
Then I can use some help to get fast CLI.
Arcade info OpenFAS.
The password.
Yeah, so you get the password and the port forward command. You need both of those lines. Yeah, you can probably paste in all of that.
There we go.
Okay.
I will do it over here.
In fact, you don't even need the port forward. Just get the password as well from the... Because you didn't obtain the password, you just echoed an empty string. There we are. Okay, then you can log in.
Here we are.
And if you do store deploy node info, then I have your IP here that I copied down. Share mine again. So I'm going to function /node info. And I'll also go to the top. So there's the login that you would normally see with OpenFAS when you try to hit someone else's gateway. I'm not going to try and log in this time. And then node info. I need to put the word function in there. So I'm guessing that's still being deployed to your cluster because it's spinning around. There we are. So, it's 64-bit on. So you're running Ubuntu.
Indeed.
So, what have we just done from the beginning?
We installed the Inlets operator, and the Inlets operator is configured with my license of Inlets Pro and a token for DigitalOcean, so it's able to create exit nodes on my preferred cloud provider. And by installing the Inlets operator, we do have some kind of controller available in the cluster that will listen on the creation of services of type load balancer. And as soon as a service is created, an exit node is provisioned with the Inlets Pro exit node, and a tunnel is created.
So do you have a DigitalOcean CLI? Could you show us? This is a really verbose one. It's compute droplet, I think. Hi, Paul Diaz. Good to see you here. And we have another guest, Shiranua. Thanks for joining us. So you've got two there, actually.
Yeah. One for the gateway of OpenFAS and one for the Nginx ingress controller. Yeah.
Great. Now, as the GIF showed us that Ivan had put together, if we delete the service, so let's say the OpenFAS gateway external service, let's see what happens next.
I'm going to show the logs of the Inlets operator as well, so we can follow
that would be great.
what's going on.
Yeah. deploy. Okay, you go for the pod. Cool.
And now kubectl delete.
I actually wonder if before you delete that, can you get the CRD and show us that? If you kubectl get. Yeah. What about in all namespaces? Hi, Kamal. Thanks for joining us.
So we have 2 of them.
So we have 2. One of the things that I quite like to do is get this output and watch it with a -W. Then when I deploy a service, you can see it going through all the stages. So provisioning, active, no IP, then getting the IP, and that can be quite interesting as well. So when we basically delete this, we should see the logs in the bottom, and then we'll get the tunnels again. We'll see that resource has been deleted.
Okay.
Okay. So deleting the exit node.
Yep,
It's gone already. It's already gone. Now, one thing that I thought is maybe run the get tunnel command, but without the watch. You actually just want -W at the end. Yeah. Now, if you can get another terminal, so we have all 3. Yeah, and then I guess do arcade info inlets operator, because that gives us a really nice command that we can just run to get an ingress, an Nginx pod, and that's what you need. So just above that, scroll up a little bit. So the apply and the expose.
This one.
Yeah, both of them.
Yeah.
So that creates us a deployment, and there's no need for the operator to create anything yet. And then expose it. There. Now we see the status provisioning. You could probably delete that little extra terminal now. There we are. So now it's detected the tunnel. It had no status. It added the status of provisioning. It will next probably go into an active status, and then it will get an IP, and at which point we'll be able to access it. Now, somebody's asking, how can you test the speed? Well, let's have a quick look. That's the IP of that is 138.63.160.81. Have I got that right? Okay, now I have on my screen, I'm going to share everything now. See Stream Deck as well. So I have a tool here called Hey, and Hey can do a load test. You've probably heard of it. But I'm going to be kind to Johan's computer. I'm not going to be too rough with it. You go for 30 seconds, 10 connections at once. Probably going to say I don't want to go any more than 50 requests per second. Now you can see on my browser here, here's the Nginx, right? And if we go and find something that's not there, it's not going to work, right? Just as we expect. So let's run 30 seconds against it. Your poor Raspberry Pi is probably going to get really warm. And so this is how you can test it. You know? And with anything, you should always test it with a real application, because obviously Nginx is going to be very quick, even on a Raspberry Pi. And also remember that any traffic that you're serving is going to go first from your computer to your exit server, and then to the end user that's accessing it. So we've always got that hop in place. Now, we did 200 requests per second. If we increased the concurrency, we could go higher, we could go faster, and also put a limit on there as well, so we didn't fry it. Again, like if you do decide to do a performance test, be kind. Don't go and try and take somebody's website down. Always build a structured test that you can reason about, be scientific, tune one thing at a time. We want a scientific test, and you see in that case, we got a similar rate on an unbounded test. Right? It's just a Raspberry Pi there. Right? It's not a serious PC. Okay, so I guess you want to probably delete those tunnels, right? At some point.
Yeah. It's just deleting the services like we did before.
Yeah.
The open files.
Exactly. But the other thing that the operator can do, and this is probably the one that's most interesting for people at home, is that it can also ignore a service. So if there's one there that you know you're going to use metal LB to look after, or you just don't want to expose it, you can put an ignore annotation on that as well. Okay. Now, when we were chatting earlier, Johan, you said you had a couple of other sort of demos, permutations on this to show us. What else have you got that you could show?
Something else I can show is the diagram we displayed earlier with the WordPress on Google Cloud, for example, and the MySQL database running on my device here at home.
So we could run through that now.
Yeah, sure.
That would be cool. Yeah. We have another few people joined us. Arijit, thanks for joining the stream. We're currently looking at Inlets, and we've gone through a number of scenarios running this on our Raspberry Pi cluster, local development environment, and also talked about how we could use it for hybrid cloud and multi-cluster. Some of the companies that are doing that. Okay, what have we got here? Are there any guides for ML pipeline using FASD on an ARM edge device? Well, there aren't any blog posts that I'm aware of using FASD and a TensorFlow unit or GPU. However, it is possible. People have done it on Kubernetes. And so you just go ahead, give it a try. And I think that would make a really good use case. Right? You've got a device out in the field. It's got a GPU on it or a TPU. It's able to run inference, maybe on the camera or some sensor data, and you're saving money. So rather than sending that all to the cloud, you can save money on that bandwidth by doing that inference locally. And then if you decide that there's an issue or an alert, you could send a message over MQTT. Maybe you could publish that on a REST endpoint. Okay. Anybody else ask questions? Feel free to just drop them in the chat. Okay, Johan.
So I switched to my cluster on GCP because the context is highlighted here.
Yeah.
And what we are going to do is we're going to bring a MySQL database that will be running on my site, on my machine, available in that cluster so WordPress can use it. And hopefully we will see that WordPress is starting up and we can start writing blog posts. That's the idea. For this demo, I will not use the Helm charts, just to give you an idea what the YAML file would look like if you want to do it manually. So let's first have a look at the MySQL tunnel part. So it's basically a deployment with one replica, and we will start Inlets Pro container with it.
Now, is this the TCP or the HTTP?
TCP.
Okay.
TCP,
why do we need that one?
Because we are going to expose MySQL. It's not an HTTP application. So it's basically TCP traffic that we are going to tunnel.
And you know, one of the things that separated Inlets Pro and the open source version previously was that whilst you could put HTTP traffic over Inlets Pro using a TCP tunnel, you could also use the open source version. And so now Inlets Pro binary actually has all of the HTTP capabilities, and we've made them even better, and the TCP.
Yeah.
So Now you can choose, is it Inlets Pro HTTP or Inlets Pro TCP, depending on what the use case is that you have.
Yeah.
What other parameters have we got if people aren't used to seeing these, like the auto TLS and the common name, etc.?
Yeah, so in this case, we won't be using an Nginx in combination with a cert manager to get some certificates for a secure tunnel. So in this case, we are enabling the auto TLS of the Inlets Pro, meaning it will create a certificate on its own for the control plane. And in this case, I do have already a domain available. It will make it a little bit easier just instead of typing an IP address. And by using that flag, the certificate generated by Inlets Pro will also contain that domain name. And then, of course, there is a token that is shared between the server and the client to do the authentication. The token is already available on the cluster. I created it before we started, so that can be used there. And so here we mount the secret with the token available. And then I will create two Kubernetes services, one of type load balancer, so it's available and reachable from my home and for everyone else, of course, as well. But I'm only going to expose the control port, the control plane port of the Inlet server. So that's for making the tunnel from the client side. And the other service is of type cluster IP, meaning it's only available from within the Kubernetes cluster. So that's where the WordPress application will connect to, and making the connection to the tunnel and accessing the MySQL database on my side.
So the data plane is private within the cluster.
Yeah.
The control plane is, what's the control plane again?
That the control plane is used by the clients to make a connection to the tunnel.
That's the WebSocket, right?
The WebSocket, the secure WebSocket, indeed.
Okay.
Just going to see if the pod is running. It's still creating.
So we're creating the server pod on your GCP cluster. Cool. Okay. And then is the MySQL, where is that? Is that running on your Raspberry Pi on systemd? Is it running in a container? Is it running on Kubernetes?
It's not running yet.
Okay. How are you going to run it?
I prepared a Docker Compose file.
Okay. Okay, so it will run in a Docker container.
Yeah, it will run in a Docker container. I prepared Docker Compose.
Can you make that a bit bigger?
Yeah.
As always, trying to make things bigger. That's just me.
Yeah. So it's a Docker Compose file, and it will contain two Docker images, Docker containers. One with MySQL, of course. And as you can see, I started with an example with WordPress available locally, but I put it in comment, so it will not start it. And then at the bottom, the Inlets client will be started as well, making connection to the Inlets exit service we created on GKA. And the token and the license is, of course, also necessary. And in this case, the upstream will be the host name DB, but it's the service running in the Docker Compose file. And the port is 3306. That's the default port of MySQL. And it should work, hopefully, fingers crossed.
Okay, so we're seeing MySQL is going to come up, the Inlets client is going to come up, we're getting all of the logs. And it just shows that Compose still has a place, it's still a very useful way of running a stack as an alternative of local Kubernetes. And well, it's connected because
it's connected.
It's told the server what ports it needs.
Yeah.
Excellent.
So now the MySQL database running on my machine in Docker with Docker Compose is available in the cluster.
What next?
Next step is have a look at the WordPress. It's a very simple WordPress deployment. It's not production ready because I'm not using a volume and so on and so on, but it's just for demo purposes. And you can see it's starting the WordPress image, the latest one, the environment variable. So the WordPress DB host is my internal Kubernetes service in the cluster, and there are some shared username and passwords.
So that MySQL, is that the service name of your Inlets tunnel?
Yeah.
And that should have the same port then, 3306. Now that isn't really in your cluster, is it? It just looks like it. It's almost like a virtual service in the world of Istio, for instance.
Yeah, absolutely.
Okay.
Takes a while.
Okay, we'll wait for that. We've got some time. And if anyone wants the slides that I showed earlier, you can go and grab them on this URL. There's also a discount code on there for 10% off a personal license of Inlets Pro. So if you want to play around with it, you can get a free trial. Or you're welcome to just go and use this discount code. 10% is about $30. It brings the price down to about $22 a month. Insiders, so OpenFAS sponsors, can get 15% off, so it's even cheaper. Okay, how are we doing here?
The WordPress is up and running. I didn't create a service for it, so I have to port forward. WordPress 8080 to 80. I'm not sure if I can share another window or.
You can just you can share everything, or just the browser, or yeah. Do we have any WordPress users? Does anybody want to admit to that in the comments? I haven't actually. Well, I have used it once. I tell a lie. For the new stack, submitted an article for them, but tend to like to use these static block generators. You put your code in Markdown. Once you have your Markdown files, it runs a binary or process, Jekyll, Hugo, etc., and you get a whole bunch of HTML files that you can then drop on a CDN, and it's great. Okay.
So it's a fresh install of WordPress, so now we can configure it.
Now, what happens when you're doing this? Is it touching the database yet?
I think so, certainly if we start putting things in here.
Excuse me. So we got a couple of questions about FASD and OpenFAS. I would say if you'd like to know more about that, head over to slack.openfas.io. And happy to chat with the community. Me and Johan are there too, and there's also an Inlets channel. So
it's perhaps a little bit slower than usual because the database is running on-prem, of course.
Okay. On a Raspberry Pi?
No, it's Docker Compose on my machine.
On your machine. Okay, cool.
Yeah.
Now, do you remember that password you just picked? Since people are talking about TPUs in the comments, I have to show you this gorgeous board from NVIDIA. I've yet to have time to flash it and play with it, but I'm pretty certain that we'll get FASD running on it using the TPU. And then I could expose that through Inlets, or just like Johan's done, so that I can access a TPU from my Amazon Kubernetes cluster or wherever. Okay, so what do we got?
Now the WordPress instance running on GKA on Google Cloud is accessing my database through an Inlets tunnel.
That's very cool. If you were to look with a MySQL client, I assume that you would have then seen all the tables, etc.
Yeah, indeed. Just
now
shut down the database and
seeing what happens, seeing if it will gracefully handle that or not. Who knows? I guess WordPress isn't designed to run without its database. That was a great demo. Thanks for walking us through that. Now, we had sort of 8 or 9 minutes left. Was there another demo you wanted to see if you could show us quickly, or how should we spend the rest of the time?
I did prepare the demo with the Prometheus and the multi-cluster, but I think it will take a little bit longer than 8 minutes.
Okay.
But perhaps we can try to get it done if you want to.
I was wondering if anybody had any questions in the comments. Feel free to ask away there. Now, one of the things that sometimes people have asked about is, is there going to be a managed version of Inlets, like a SaaS? I'm not sure, to be fair, whether that's something that we'll want to do, but we spent a lot of time making it very easy for you to run it yourself. In particular, like the multi-tunnel use case. In fact, since we don't have as much time to go through the multi-cloud, let's see if I share my screen again and show you a quick demo. I go to the Inlet. I have this Inlets cloud project with its own CLI, and what it does is it has an additional CRD, like you would have. We have that tunnel CRD on Inlets operator. This is a different one. This isn't meant to create cloud VMs. It just runs in a Kubernetes cluster. And what I can do here is list tunnels that I've got. And I can go and create one as well. So if I wanted to, I could create a tunnel for Johan now. And it was that fast. If I look at my pods in the Inlets namespace, I'll see Johan's one is just there from 11 seconds ago. And the cool thing is I don't have to go and get a load of secrets. I just type in connect, the tunnel, and the domain, which is this. And it's then given me the exact connection string. So just like, if you were using a managed database, this is the kind of experience that you would have in your EKS cluster. So if I give you that, Johan, on OpenFAS Slack, just send that over to you. You should be able to connect a tunnel to that, and then we will all be able to access it using this address. And running. And on my side, I can go and get the logs for that. So this is using a deployment. Let me see if I can remember what it's called. So you even make mistakes with Kubernetes, which you've been using as long as I have. Okay, I've got the logs. There was a connection request because I assume somebody went a little bit quick and actually tried it out. I'm going to split my screen as well because it's a bit easier to look at. And let's try it out. jcbeans.
Yeah, I don't have a service running for the moment. I made a tunnel, but I don't have an upstream available.
What could you run? Maybe you could run the file sharing that we ran in the last stream that we all did together. So there is a little file server built into Inlets Pro. This is a new HTTP functionality that we've added, and what it allows you to do is just share some files. The use case might be, let's say you've got a conference talk you've just recorded. Amit's there. He does his public speaking. It's 3 gigabytes. So you can upload that to OneDrive and wait 3 hours, and then once it's uploaded, share a link with whoever is doing the conference. Or you can simply run this command and instantly share URL with them. Even have a password on it if you want. So, okay. Now it looks like you've got the enhanced security that prevents me from listing the files.
Oh, yeah, sorry.
Again, like the reason that I created this feature in Inlets is the Python simple HTTP server couldn't allow us to do a password, and it couldn't allow us to easily block people from listing the files, because sometimes it might just be easier to do it that way. So here we are. There's nothing secret in there we don't want anybody to have, is there?
I don't think so.
Okay, good. And there we are. So how quick was that? I mean, once you have a EKS cluster or GKE cluster, DigitalOcean Kubernetes running somewhere, it's simply a case of, okay, you want a tunnel? No problem. Why don't we create you one? We'll create another tunnel now. Test 1. That's created. Want the connection info? Not a problem. You just go and put in the domain. So exit test 1. There we are. You can literally connect to it. Probably less than 5 seconds to provision and connect to a tunnel. Now we also want to be able to delete these, so we can get rid of the old ones, and anybody who didn't get to Johan's yet, his is going to. Now the difference here between probably what we were talking about with the hybrid cloud and that example is we are making that service available to people on the internet, right? And let's say Johan had some stuff to share that was private. We might just not expose it. And that's one of the key things that you should understand when you think about a SaaS tunnel product, is usually that only exists to help you expose something like the Inlets operator. Here, we got the flexibility to say, well, it's up to you. I think you were setting up some tunnels recently, weren't you? Or some IPsec tunnels and VPNs at work? One of your clients?
They could use it because they were struggling with the VPN setup from on-prem to the Google Cloud, just to expose some services. So in that case, Inlets would be definitely a good choice.
How long do you think it would take you to set up a VPN from scratch, or set up an Inlets server and client? Is there a difference, like in the initial setup?
For me, it's a big difference because I'm not familiar with setting up VPNs. And like we demonstrated during this talk, it's in a few minutes you have an up and running tunnel available.
Yeah. Would you have any advice for somebody who was sort of not familiar with Kubernetes, maybe felt a little bit overwhelmed by all the different words we're using and all the concepts?
Start with the basics. Learn to create some pods, see how it works, and then build on that. So have a look what kind of services there are available, what's the difference between a cluster IP and node ports and load balancer. And start with the basics. What's a pod? What's a deployment? And then you can go further with all kinds of difficult things like Helm or Customize. It's a very big ecosystem, for sure.
Yeah, I think I would agree with you there as well. Always just start at the beginning. What is the simplest, most repetitive manual thing you can do on day one? And then as you sort of have a deeper understanding of that, how can you start to maybe reduce some of the repetition? Maybe there's some courses that people get on well with. Feel free to tweet that to us later. And so to sum up, we said that in those slides, Inlets with Kubernetes can be used to get my Jetson Nano with K3s, a public IP. It can be used to get a hybrid cloud where my legacy app is partially on premises still, and some of it's in the public cloud. And then it can also be used for multi-tenants, multiple customers, where I want to monitor or observe or charge them on a regular basis and sort of get some data out of their cluster back to some central control plane. And there may be other use cases too. Kubernetes is completely optional here. We've really just got a binary that's also available as a Docker image. And so it's up to you guys how you want to run it, where you want to run it, and how to automate it. Okay, so if you want to find out more, and also if you want to read that blog post that Johan wrote, how we scaled to thousands of tunnels, go ahead, check out inlets.dev. Likewise, you guys have got that discount code if you want to use it, or kick the tires for a free trial. No. So I think that's it for our mini series on Inlets. If people do have suggestions, feel free to give us a shout on Slack or Twitter, and we'll see you soon. All right. Goodbye, and thank you, Johan. Really enjoyed the demos.
You're welcome. Thank you for having me.
All right. Bye-bye.
Bye.